Hi, my students. How are you today? Assalamualaikum warahmatullahi wabarakatuh, everybody. This lesson 77, chemical reactions of carbonyl compounds, is going to be a bit long, but you're going to learn a lot. Today, we're going to learn a lot of new reactions. Among them are nucleophilic addition with its mechanism, reduction of carbonyl compound to form alcohol, condensation with ammonia and its derivative, oxidation of aldehyde, and several tests: Tollens, Fehling's, BENEDICTS and SCHIFFS test, Iodoform Test to identify compound with structures of carbonyl methyl and hydroxymethyl. Then we're going to state the importance of carbonyl compounds. This is what makes carbonyl compound unique. We have an electropositive part at the carbon atom and electronegative part at the oxygen atom, as oxygen is an electronegative atom. Oxygen has a strong tendency to pull electrons towards itself, and this will make the carbon-oxygen double bond a very polar compound. Because of the high polarity of the carbonyl compound, as shown in the structure here, aldehydes and ketones are susceptible, are prone to undergo nucleophilic addition. What makes carbonyl carbon is open to be attacked from above or below is the trigonal planar arrangement and the positive charge of the carbonyl carbon. The negative charge on the carbonyl oxygen means that nucleophilic addition is prone to acid catalysis. Let's open the mind map now. The first reaction for carbonyl that we're going to learn is nucleophilic addition. There are three reactions. Number one is the reaction of aldehyde and ketone with HCN. HCN is the reagent, hydrogen cyanide. And then the second one is H2OH plus. This is a reversible reaction. And finally, the one that we have learned previously in chapter 8, when we are producing alcohol, is the reaction of carbonyl compound with Grignard reagent and H2OH plus, which will produce primary, secondary, or tertiary alcohol. Let's look at the general reaction of nucleophilic addition. As you can see here, this is an aldehyde whereby it is going to be reacted with a nucleophile. That's why we call this reaction nucleophilic addition. We add nucleophile into the carbonyl compound and we are going to get an alcohol over here with a nucleophile attached to the carbonyl carbon, the originally carbonyl carbon. The carbonyl group will undergo nucleophilic addition whereby, since it is polar, the electropositive charge of carbon atom will be attacked by nucleophiles such as cyanide ion and hydroxide ion. Let's do the first example, 9.4 reaction of ethanol with HCN. What happens in nucleophilic addition is that the nucleophile will attack the carbonyl group from below, so that it is going to attach to the carbonyl carbon together with the H plus that is coming in with HCN, the reagent, and the compound that we got from ethanol here is called 1-cyanoethanol. Now, let's do the second example of 9.4 by using the reactant propanol. Now, it's a ketone together with the reagent HCN, hydrogen cyanide. And here, Cn minus is again the nucleophile that will attack the carbonyl group from below. It will attach to the carbonyl carbon like this, and the proton H plus is going to be attached to the carbonyl oxygen. And now we're going to get 2-cyano. The Cn is attached to carbon number 2, and 2-propanol. The hydroxy group is also attached to carbon number 2. Okay, the second nucleophilic addition is by reacting any carbonyl compound with water. Water together with an acidic environment, H+. So what happens when the nucleophile is an OH minus? OH minus will also attack the carbonyl carbon from below, and it will produce a germinal diol. A germinal diol is basically a carbon where there are 2 OH groups attached to it. So here we are getting a propan 1,1 diol. Let's do question number 2 by using propanol as the reactant. OH minus as the nucleophile will attack the carbonyl carbon over here and attach to it, so that we are getting another gem diol, which is now called propan 2,2 diol. Okay, now question number 3 is using butanol, another ketone. So what happens here is that we're going to get another gem diol, and the name would be butan 2,2 diol. Okay, so nucleophilic addition for the third type of reaction is involving a Grignard reagent, meaning that we have seen this reaction for the third time now. The first time in chapter 7 when we are making the Grignard reagent, and the second time when we are forming the alcohol in chapter 8. And now in chapter 9 we are looking at how carbonyl compound react with Grignard reagent together with the condition H2O and H+, to get what type of alcohol? This is an ethanol, an aldehyde. For aldehyde, if we react it with, this is an ethyl magnesium bromide, we are going to take the nucleophile of Grignard reagent here, and then we are going to take the H+ from the condition attached to the carbonyl, the originally carbonyl carbon, like this, and we are going to produce a secondary alcohol, which is called 2 butanol. Notice that 2 carbons are coming from the aldehyde that we used, and another 2 carbons is coming from the R of the Grignard reagent. So total is 2 plus 2 equals to 4 carbons. It became 2-butanol. Right, question number 2 for Grignard reagent. Wow, the Grignard reagent has a cyclic substituent. Never mind, it's simple. Just take it with you when you are attacking the carbonyl carbon. So, what we are going to produce here is a secondary alcohol, whereby, as you can see here, the carbon that is attached to the magnesium bromide is basically attached to the originally carbonyl carbon. So, the cyclopentyl also is attached to that carbon, as you can see here. So, we are going to take together with us 3 carbons from this aldehyde, the 1,2,3 propanol, and we're going to attach it with the R from the Grignard reagent over here, and then we're going to get the proton H plus coming from the environment, the condition H plus, and we are getting 2-cyclopentyl 3-pentanol, another secondary alcohol. Right, let's do one reaction on ketone. This is a butanone, and it is reacting with, wow, a Grignard reagent with an aromatic ring. Okay, just bring it with us while attacking the carbonyl compound. So we are going to attach the R from the Grignard reagent over here to the carbonyl carbon over here, and we are going to get a tertiary alcohol, whereby, okay, in purple here is the R from the Grignard reagent. You can see the aromatic ring is attached to the carbon, and the hydroxy group is on top here, completed by the attachment of a proton from the condition. So now we are doing 3-methyl 2-phenyl 3-pentanol. Okay, in chapter 9, we are going to learn the mechanism of nucleophilic addition. Step 1 is the nucleophilic attack. In the reaction, nucleophile would be, it's either cyano ion, hydroxide ion, or Grignard reagent. So, the first thing that is going to happen is the nucleophile will attack the carbonyl group from below. The place where it is attacked is at the electropositive part of the carbonyl group, which is the carbonyl carbon. What happens next is the double bond will lose its electron to oxygen, since oxygen is electronegative. This step 1 is a slow reaction where nucleophile will be attached to the originally carbonyl carbon, and the oxygen atom is gaining a negative sign. The second step is a fast one, whereby proton H plus is going to be attacked by the oxygen which has the negative charge. And then the final product, an alcohol, is going to be produced. Let's do example 9.7 in your page 313. Write the equation for the reaction of propanol with HCN, then give the name of the product formed. Show the reaction mechanism. Let's answer this question together. The first thing that you need to write is the reaction. So write the reactant, propanol, the reagent, HCN, and then the product, where you attach the CN to the carbonyl carbon, which has the hydroxy group. The name of the product is 1-cyano-1-propanol. Now let's do the mechanism. What is the first step of the mechanism? Yes, nucleophilic attack. First, we need to attack the carbonyl carbon, the electropositive part, with the nucleophile. Basically, Cn- is attacking the electropositive part, and then the double bond is going to give its electron to oxygen, the electronegative part. This is a slow reaction. Don't forget to write this down. And then we're going to get an intermediate whereby Cn is attached to the carbonyl carbon and oxygen is having a negative charge. Next step is addition of proton. Proton H+ is attacked by the negatively charged oxygen fast, and it's going to produce 1-cyano-1-propanol. Voila. Please do practice 9.3 on your own so that you can test yourself whether you understand nucleophilic addition or not. Now, we are moving on to the second type of chemical reaction for carbonyl, which is reduction. Reduction of aldehyde is going to produce a primary alcohol, whereas reduction of ketone is going to produce secondary alcohol. We have a lot of reagents involved. We can use hydrogen gas with palladium, platinum, or nickel with heat. We can use NaBH4. We can use Li aluminium hydrate, lithium aluminium hydrate in ether and H+. Also, we can use zinc H+ and heat. Page 315, example 9.8, question 1. Ethanol is undergoing reduction using reagent, hydrogen gas, platinum, and heat, producing a primary alcohol and ethanol. Question number 2, you have an aldehyde over here where we are going to reduce it using sodium boron hydride. We are going to get again a primary alcohol, as we are going to attach the H+ at the carbonyl oxygen, and then the double bond is going to be used to form another single bond together with another proton from the reduction reagent. For question number 3, we are drawing a propanon. Here is a propanon where we are going to use a reagent, lithium aluminium hydrate with ether and hydrosodium ion. Then we are going to produce a secondary alcohol because the carbonyl carbon is already attached to 2 R's, even from before it was reduced. For question number 4, this is a cyclohexanon. It is going to be reduced by zinc, H+ and heat to produce a cyclohexanol secondary alcohol. Okay, class. Now we are looking at the third chemical reaction of carbonyl, which is oxidation. We have done only one. The first one is the oxidation of aldehyde. Remember, we learned this in chapter 5 when we are doing oxidation on alkene, and then we are going to oxidize the aldehyde further into a carboxylic acid. Now, the other reactions are called chemical tests because we can use only a small amount of reactant and reagent for an experiment in the lab using the test tube. You actually have done this. So at the end of this week, you should be able to submit the lab report for experiment 6. The second oxidation is tolerance test, where we are going to form a silver mirror. The third is Fehling. The fourth is Benedict. And the last one is SCHIFFS. Let's fast forward to practice 9.4. And you can see the table on that page is the same as this one. When we have aliphatic aldehyde, it would be positive for all the oxidation tests. But if it's a benzaldehyde, an aromatic aldehyde, it's going to be positive only for oxidation and tolerance. For propanol, it's going to be positive only for shift. And for aliphatic ketone, together with aromatic ketone, it's going to be negative for all the oxidation reactions. The oxidation reaction happens only for aldehyde. Why? Because ketone doesn't have a hydrogen attached to the carbonyl carbon. The reagents that can be used as oxidizing agents are potassium permanganate, potassium dichromate, and also silver oxide. Let's do example 9.9 in page 316, question number 1. The first reaction is using potassium permanganate. So all you have to do is add oxygen, add the carbonyl carbon, making the product a carboxylic acid. Question number 2, also the same thing. We are doing the oxidation using potassium dichromate now. Just attach one oxygen at the hydrogen that is attached to the carbonyl carbon, and you're going to get a carboxylic acid. Tolerance test is also known as silver mirror test, as we have a positive result when we produce a mirror. It's used to differentiate aldehydes and ketones because it's going to be positive for aldehydes only. The reagent is the mix of aqueous silver nitrate with aqueous ammonia. So it contains diaminosilver ion. This ion is a very weak oxidizing agent, but it can oxidize aldehydes to carboxylate anion. When carboxylate anion is formed, silver is reduced to become its atom, para. If the rate of reaction is low enough and the walls of the test tube are clean enough, the silver solid is going to be deposited on the walls of the test tube as a mirror. Tolerance test will give a positive result with aliphatic and aromatic aldehyde, but a negative result with all ketones except alpha hydroxy ketone. Shown to you here is the general reaction, the same as the one that is in your book. Then you have to write down the answer, for example 9.10, where we have ethanol reacting with the silver mirror reagent. We are going to get this product together with a silver mirror. The arrow going down is compulsory for you to write because it shows we are producing a precipitation, a solid form of silver. Okay, now let's look at Fehling. Fehling solution consists of copper 2 ion made up by mixing copper sulfate with alkaline sodium potassium tartrate. It can be used to distinguish aliphatic aldehyde and aromatic aldehyde. So it will give a positive test to aliphatic aldehyde but negative test to aromatic aldehyde and all ketone. The most important part that you need to know here is the observation. What is the observation when the reaction gives a positive result? Blue color of copper 2 plus ion is reduced, becomes colorless, and then it turns to brick red precipitate. Here is the general reaction of the Fehling's reaction. We are not going to ask you to write the whole thing. Just focus on the observation. Brick red precipitation occur, and then you should be able to replace the R with a methyl group here because example 9.11 is using ethanol as the reactant, producing an ethanoate together with a precipitation brick red of copper 1 oxide and water. Let's look at Benedicts now. Benedicts are using citrate complex as reagent. This is the general reaction where we are going to have the same observation as Fehling's, where ion of copper, 2 copper, originally blue in color, is going to be colorless, and then it's going to produce a brick red precipitation as well. For SCHIFFS reagent, it's a bit complex, so we're not going to show you the equation. We just want you to know the observation. When aldehyde reacts with SCHIFFS reagent, it's going to give out a pinkish purple solution. This color will show that it's a positive test for aliphatic aldehyde and propanol. It's not going to give a positive test to benzaldehyde and other ketones. The fourth reaction that we are going to learn about carbonyl compound is iodoform test. This is an important test that you must know. The reagent used in this test is iodine in sodium hydroxide solution. And this test is formed to detect the existence of a methyl group attached directly to the carbonyl carbon. The same as alcohol, if it's positive, the group detected is methyl hydroxy. For carbonyl, the group detected is a methyl carbonyl. So, as shown to you in the slide, that is a structure of the group that we are going to detect using this test. If it's positive, it's going to be a yellow precipitate. So now you can go back to the results on experiment 6. Which compound has a positive result for iodoform test? If it's positive, it would have a group which is called the methyl carbonyl group. The C double bond O is attached to a methyl group directly. In this example, the equation shows that the reactant is a 2-butanon. Therefore, the reaction is going to produce a CHI3, which is a yellow precipitation of a solid. Let's do example 9.12. Again, this is a butanon going to be reacted with iodine and sodium hydroxide. Okay, write down all the products listed here in your page 319. And most importantly, you need to write the triiodomethane, the yellow precipitation. For question number 2, we have a ketone whereby the carbonyl group is attached to a benzene ring on the left and a methyl group on the right. So it has a methyl carbonyl group. So when we do iodoform test on it, it's going to form, yes, a triiodomethane, which gives a yellow precipitation. The fifth reaction on carbonyl that we're going to learn is a condensation reaction. This is an aldehyde or ketone. What happened is, when we react it with an ammonia or any ammonium derivative, H2O is going to be removed from both compounds. They are going to merge after that. So the oxygen coming off from the carbonyl group, and then 2 hydrogen atoms coming off from the ammonia. So here we can see there is a Z group will be attached directly to N, and then N will be attached double bondedly to the originally carbonyl carbon. Table 9.2 is listing all the derivatives of ammonia which we have to know and its product reaction with any carbonyl compound. Number 1 is hydrazine. When reacted with carbonyl compound, it is going to form a hydrazone. The second one is hydroxylamine. It is going to form an ozine. Next is a phenylhydrazine, because we have a benzene ring over here attached to the N. And when phenylhydrazine is reacted with any carbonyl compound, it is going to form a phenylhydrazone. This is the general formula. The next one is called 2,4-dinitrophenylhydrazine or 2,4-DNPH. 2,4-DNPH is known as the BENEDICTS reagent, the one that you also have done in the lab experiment 6. If it's positive, it's going to give an orange crystal precipitation, meaning that the compound that you are tested with this BENEDICTS reagent has a carbonyl group. Doesn't matter whether it is aldehyde or ketone. So it is going to form a product like this. Let's do example 9.13, question number 1. This is an ethanol. It is going to react with hydrazine. So we are going to take off oxygen from the carbonyl group and 2 hydrogen from the hydrazine. It is going to form a hydrazone. So you attach the carbonyl compound part directly to the end that lost its 2 hydrogen. Question number 2, we are reacting a 1, 2, 3, 4, 5, a pentanone with a hydroxylamine. So we are going to form an enzyme over here whereby this carbonyl compound part is going to be attached directly to the end of the hydroxylamine which lost its 2 hydrogen atom. The byproduct will be water. Let's do these extra questions. There's no space in your course book. Let's do this in a different piece of paper or in your exercise book. Write chemical equations when propanol reacts with hydrazine, hydroxylamine, phenylhydrazine, and 2,4-DNPH. There are 4 reactions that you have to do for propanol. 4 marks for you there. Another 4 marks is when you write down the equation for the reaction of 3-methyl-2-butanone with hydrazine, hydroxylamine, phenylhydrazine, and 2,4-DNPH. Do this and you will pass this reaction smoothly. We have finished 5 reactions on carbonyl. So that's it for chapter 9. We will see each other again in 2 more chapters, carboxylic acid and amine. Thank you very much for watching and writing down the examples. Assalamualaikum warahmatullahi wabarakatuh. Bye.